Now we're going to learn how to write the equation of a line given a point and the slope. So previously we've learned about slope-intercept form, y equals mx plus b, and standard form, ax plus by equals c. Today you're going to learn about point-slope form, and that has the formula y minus y1 equals m times x minus x1. So that y1 and that x1 might remind you of the slope formula. And in fact, this formula is based on the slope formula. If you noticed, if you divided both sides by the thing in parentheses, x minus x1, you'd pretty much end up with that slope formula again. So that's where it comes from. Let's learn how to use it. If we know a point on the line and the slope of the line, we can plug in our given point into x1, y1. So x1 is going to be the x value of the 1 point, and y1 is the y value of that 1 point. Plug the given slope in for m, and then leave the regular x and y alone. So we'll be replacing x1 and y1, but not the y and the x, because we still want to have an x and a y in the formula. And then we will solve for y, because we want our final answer to be in slope-intercept form. Slope-intercept form is a lot more useful, and it's a lot easier to graph when we have an equation in slope-intercept form. Let's go ahead and try out some examples on paper. So for our first problem, we know the line goes through the point 6, -3, and m, the slope, is -2. And as a reminder, here is our point-slope form. Let's solve this. So I'm going to substitute in all these values. So I'm going to start with y. I don't do anything with the y value. Minus y1. So I'm going to write minus and then the y value, that y1 value. This is y, so it's -3. So I'll plug in a -3 here. Equals, my slope is -2, so that's replacing m, parentheses, x, and we leave the x alone, minus x1, so that first x value of 6. Now let's simplify this. First, I notice I have y minus a -3, and I know if I have minus a negative, that's the same as y plus 3 equals. On the left side, I can distribute this. So I have -2x, -2 times -6 is a +12. And then because I want it in slope-intercept form, I'm solving for y. So to get y by itself, I'm going to go ahead and subtract 3 on both sides. That cancels. Y equals. These are like terms. They're both constants. So I keep my x term, minus 2x, and 12 minus 3 would be 9. So my final answer in slope-intercept form is y equals -2x plus 9. My slope is -2, and my y-intercept would be 9. Let's try the next one. I've got a point and I've got a slope, so that means I should use point-slope form. The name tells me what I know. So to write down the general form again, y minus y1 equals m times x minus x1. I'm going to fill in all my values. Keep the plain y. y1, the first y value here, is 4, so minus 4 equals m, my slope, 3/2, parentheses, keep x, minus x sub 1, -2. And again, be careful that you've written x minus a -2. Now I solve for y. I'm going to keep this like y minus 4 for now because I can go ahead and distribute on the right side. Well, actually first I'm going to go ahead and make that a plus to make it easier. So distribute, 3/2 times x is just 3/2 x, and then 3/2 times 2. And as always, you can multiply with fractions off to the side. You can make that a 2/1 if you want, but the 2's are going to cancel. I've got divided by 2 and a times 2, so it's just 3. And now I can get y by itself by adding 4 on both sides to get y equals 3/2 x plus 7. The next one, my slope is 0. Let's fill in the point. Y minus my y value of -7 equals m, which is 0, x minus a -4. So I've got 2 minus the negatives here, which I will go ahead and make plus. So over here I've got y plus 0 equals 0 times x is 0, not 0x, just write 0. 0 times 4 is also 0. So really this whole side is just 0. I still want to get y by itself, so I'll subtract 7 on both sides, and I end up with just y equals -7. That's a special case equation. Remember our special acronym HOI and VUX? If your slope is 0, that makes us think about HOI. So it's got to be a horizontal line with a slope of 0, and the equation has to be y equals a number, which notice, that's what we end up with. So if you realize it's a special case, you can save yourself a little bit of time. Last example, point is 3, 4, and the slope is undefined. Well, I really can't put undefined into my form and then try to distribute the word undefined. That's not really going to work. But since I just did that last problem, I'm thinking about my special cases, and undefined makes me think about VUX. A vertical line has an undefined slope, and its equation must be x equals a number. Well, what does x equal if I look at this point? X is 3. So the equation has to be x is 3. What if I want to find the equation of a line given 2 points? Well, there's no such thing as point-point form. You do need the slope and a point to write the equation. Luckily though, if I have 2 points, I can find the slope with my slope formula. y2, and remember to get that subscript, you can click Control and less than to type a 2, hit Control less than again to get out, minus y1, Control less than 1, click down to the bottom, x2, x, Control less than 2, Control less than to get out, minus x, Control less than 1. There's my slope formula, and once you know what the slope is, you can plug in the given point into x1, y1, and it's the same thing we were just doing. Plug the slope in for m, leave your regular x and y alone, and then solve it for y to get it into slope intercept form. Let's try the examples. We have our 2 points. We're going to start by finding the slope. So y2, which is -4, minus y1, 6, over x2, 3, minus x1, 1. Simplify both parts of the fraction. My numerator, -4 minus 6 would be -10, and 3 minus 1 is a 2. And -10 divided by 2 is -5. So I'll just write down that m is a -5. So now I have enough information to get an equation written down. So my slope is -5. And I know I want to leave the y and the x alone, but which point do I use? Because this time I have 2. Well, it really doesn't matter. You can pick either point as long as you pick that one point and use the same x and y, so you can't use this x and then that y. It's really up to you. I am going to use this first point because I like that there's no negatives and it's got a 1, which is a nice small number, but you could just as easily use point 2. Just pick a point and use it. So minus my y value of 6 and x minus the x value of 1. Now to solve this for y, I will distribute. Y minus 6 equals a -5x plus 5. Add 6 on both sides to get y by itself, and y equals a -5x plus 11. Next one, got to find the slope in order to write the equation. So slope formula is y2, which is -1, minus y1, 4, over x2, -5, minus x1, also -5. So that's going to become a plus. I get -1 minus 4 more is -5. -5 plus 5 is 0. What happens when we divide by 0? It's undefined. Wait a second, that's a special case slope. Got to think about Hoy Vux, and if it's undefined, we want to think about Vux. A vertical line has an undefined slope, and its equation has to be x equals a number. What does x equal? Oh look, the x's were the same. They're both -5. So that's got to be my equation. And if I'd noticed at the beginning that the x's were the same, we could have skipped straight there. Number 3, y2 minus y1 over x2 minus x1. Go ahead and make both of those minus and negatives into plus. -1 plus 3 is 2, and 2 plus 2 is 4, and I can reduce 2/4 to 1/2. Let's pick a point. I'm going to pick this one since the numbers are a little smaller. It doesn't matter though, you could choose this point. Y minus y1, which is -1, equals m, my slope, 1/2, x minus x1. Change that to plus, distribute 1/2 x, half times a -2. 2's do cancel out. -1 times +1, it's just going to be a -1. -1 on both sides. And y equals 1/2 x minus 2. Last one, find the slope. -3 minus a -3 over 8 minus 4. Minus a negative becomes a plus. -3 plus 3 is 0. 8 minus 4 is 4. 0 divided by 4 is 0. So my slope is 0. Now I could put that into point slope form and solve for y, but I remember that if my slope is 0, that's a special case. And we want to use Hoy. A horizontal line will have a slope of 0, and its equation has to be y equals a number. And what do we notice both y equal? -3.